All right, guys. Well, welcome to today's class. Today is September 16th, 2020. If you missed class today, this is what we went over. I'm going to do a little bit faster than what we did in class. That way you can watch this video and you can do your assignment. So on Monday and Tuesday, what we did is we talked about this new concept called graph theory. We looked at these new images called graphs, which are not the XY axis anymore. Those aren't the types of graphs that we're talking about. We're doing in this particular class, especially in this particular unit. These graphs are now look like those dots and lines that I have right here on the screen. They are made up of these dots called vertices. Vertex is singular, and every line is called edge. And we use them for a variety of reasons. And it's in a lot of careers and a lot of practical applications in real life. We learned also how to find a Eulerian path in a graph. A Eulerian path is a path through every edge, and I use every edge exactly one time. And so this is the example that we left with on Monday and Tuesday. And I was able to find a Eulerian path in this particular graph. You can see on the screen that I started at the top right of the screen. I went over and I basically went all the way around the square. I came down the middle, and I did a little loop, and I actually ended where I started. So in this particular way, if I find a Eulerian path that I start and end at the same vertex, that actually becomes what's called a Eulerian circuit. So a path is using every edge exactly once. A circuit is using every edge exactly once, but also starting and ending at the same vertex. So those are the two concepts that we have kind of right now that we're going to be working with. So in class today, I gave students this problem to do, and we did it in a couple of minutes. I'm going to show you a solution. It says, does this graph have a Eulerian path or a Eulerian circuit? After playing with it a little while, I was only able to find a path. A circuit for this graph actually does not exist, but here's an example of a path. I started in the top left. I went around here, went around the loop, then I went up through the middle and around, and I went down to the middle. And as you can see, I did use every edge exactly once, but I didn't start and end at the same spot. I started at the top left, I ended in the middle. This is actually just a Eulerian path, but not a Eulerian circuit. And that exists, and that's a possibility for these graphs. So you might be thinking, like, can a graph be a path and a circuit? Well, yeah, it can. I mean, think of it this way. Think of it as a square and a rectangle. A square is always a rectangle, but a rectangle is not always a square. In this particular case, by definition, a circuit will always have a path because they both use every edge exactly once. The only difference is the circuits start and end at the same vertex. So, but just because a graph has a path, it doesn't always mean it has a circuit. So just gotta be careful with that. But I am going to show you a trick. I'm going to show you a trick on how to determine whether or not a graph has a Eulerian circuit or not right off the bat. And it's pretty easy. And all you got to do is kind of look at something like this. Look at these two graphs. The one on the left is the one that we did on Monday, Tuesday, the one I started out with. That one does have a circuit. We've already proved it. We found it earlier. The one on the right, the one I just did right now, only has a Eulerian path. It does not have a circuit. We looked and looked and looked, and we couldn't find one. But here's an easy way to figure it out. And what I'm going to do is I'm going to label all of these vertices on both of these graphs with their degree. Now remember, degree stands for the number of edges that touch the vertex. So on the one on the left, look at those numbers. Remember, this top left vertex has a degree of 2 because 2 different edges touch it. The one on the top right has a degree of 4 because 1, 2, 3, 4 edges touch it, and so on. And so I labeled all those vertices. That's the one that has the Eulerian circuit. I'm going to label the one on the right as well and look and see if you see a pattern. The one on the right has labeled as well. What do you notice about the vertices in the graph that has a circuit on the left? And what do you notice about the degrees of the vertices in the graph with the path on the right? And if you guess that the one in the circuit are all even, you are correct. If you have a graph and the degrees are all even, they all have an even degree, meaning every vertex has an even number of edges touching it, then the graph has to have a circuit. It has to. But if even one vertex is odd, it only takes one. If even one vertex is odd, then it will not have a circuit. It might have a path, but it will definitely will not have a circuit. And so there's the trick right there. I've written it out. It's in your slides and your notes. You can view these slides later. It must contain a Eulerian circuit if all the degrees have an even degree. If even one vertex has an odd degree, it will not contain a Eulerian circuit. And sometimes it just doesn't have either. Think of that problem I had you guys do on Monday, the one with the bridges. There was, if you look at the vertices, they're all odd, even every single one of them. And I gave you this problem to try to go over every single bridge exactly one time, and you weren't able to figure it out. And you weren't able to figure it out because it just wasn't possible. And so this graph doesn't have a Eulerian path nor a Eulerian circuit. And so that's a possibility for that to happen as well. So this is what we did in class today. It took us about 15 to 20 minutes to do this together. And then I assigned your homework for you guys. If you have not gone through Schoology enough, I just wanted to point out a few different things again as you are navigating through my class. You can always use the buttons here at the top. I update it once a week to click on the day, and it'll take you directly to what it is that you're looking for. What we're working on is obviously Unit 1 right now. And if you look at the 1.1 folder, it will give you some instructions. Hey, this is what we did in class today. Obviously, if you weren't in class, I'm going to post these videos right here. The very top, I'll always have the notes. So there's the slideshow that I just went over these couple of days. Use those for your notes to do your assignment, and your homework assignment is down here. If you did not, when you open up your homework assignment, make sure that you're logged into your school Gmail account in order to access it. You're going to use the notes in the slides to help answer some of these questions right here. Please, please, please answer in complete sentences. I know this is not English, but we got to work on our writing on complete sentences with correct grammar and pronunciation. On the back page, on the second page, this is where you're going to do your practice with these graphs. Follow the directions. You're going to do exactly what we did in the slideshow in terms of trying to find a path or a circuit. You can do one of two things here. You can actually edit these pictures and draw on them. If you double click the picture, it brings it up really big, and then you can use the draw features here. You can use an arrow, or Scribble will let you free draw on there. And I don't want to save that. I want to delete that. Whoops. So this is one way you can do it. Double click on that picture. It tells you there at the top. There's an example here too. Use numbers to help it make it see easier, and start and end, label start and end. Alternatively, if you don't want to draw, you can always just list the sequence of going from vertex to vertex. I wrote it down here. Like, I started at B, then I went to A, then I went to D, then I went to E. I just wrote the sequence, and you can do that here. If you don't draw on it, then you could write the sequence, but you don't need to do that if you draw on the assignment. If you need any help, guys, please email me, send me a message and remind. This is due on Friday at 10 a.m. This is before school starts on Friday, so please get it done. People that were in class had time in class to do this today. Many people finished it and already turned it in, so it's definitely not something that's not going to take very long. And we're going to move on to our next lesson starting on Friday. All right, email me if you need any help. Have a good one, guys.